Hi, in this video, I had a request about how to do HMI passing values from a HMI into a more object-oriented style program. So people are quite used to having structures and the HMI talking to the structure, or maybe they're just talking straight into a function block or the program variables. Obviously, there's lots of ways of writing programs, not necessarily saying any are better than others. But if you take an object-oriented programming approach, you have objects that require parameters from your HMI. And when I say parameters, I tend to talk in terms of things which are read-only for the program, where I tend to speak status as being things which I can write back and tell people, whether it be the HMI or something else. So quite often we will want to decouple our objects from the HMI itself. Now, the video that you'll see following this is an approach. So this is an approach to say that I'm going to have my HMI speak to a structure. The structure will then be wrapped in an object that looks after that structure, and that in this instance is called the HMI parameter provider. Okay, bit of a long name, but still, it's just to prove a point. And then this parameter provider can take on different guises. It can actually, in the example you'll see, I've made an entry module and an exit module. It can be the provider of its parameters. So have a watch, see what you think. As I say, there's lots of different ways of coding. This is just one of them. This is just a solution that we've used before and we've seen in real life. You may want to expand upon this to make it a bit more generic, but maybe this may solve some of your problems. Okay, this is just to run through the example. So what I've done is I've set up just pretend modules, an infeed module and an exit module. Each of those modules takes an infeed motor and an exit motor, which I'm just passing in as interfaces via the motor, via this constructor. Just to have a look at that, the exit module just takes in a motor and then just assigns it to its own internal motor, just there, speed control motor, and likewise exactly the same on the infeed. There we go. Right, if we were going to pass down, let's say this hypothetical machine needed a machine set point and it can also control its entry speed and exit speed, and this was provided by the user itself, so from the HMI, so I'd normally turn these parameters. Anything in the other direction, we used to use status. So we've got three parameters there, which these modules require. And let's say the entry needs both machine set point and entry speed, and the exit needs set point and exit speed. So a way we would tackle this in the past is to make, first off you can see I've just defined that structure and made it as a HMI parameter structure. And now I've started to put together, I haven't put any code in there yet, this HMI parameter provider. So we can obviously shorten that name, but the provider takes the structure. So if we open this up here, you can see that the parameters I'm passing in is a reference to the structure. And inside I'm just saying this object's parameters is going to equal the reference of the parameters I'm passing in. And that means inside this function block I now have access to parameters itself. So that every time I access parameters, that will be the structure that I've just passed into it. What we can now do is say, let's work on the infeed module to start with. So we'll say that the infeed module needs access to entry speed and machine set point. So let's just do these ones first. So we're going to go into this object, add properties. I'm going to make a property called machine set speed set point, may as well. Its return type is an LREL. It's public. And the get on this is going to be machine set point is equal to parameters. Machine set point. There we go. So it's just tied it straight into our structure behind the scenes. What's quite nice about this as well is it means that we can do some validation if we want. We can, in turn, inside this object, we could say if the HMI tries to set this value over and above what it knows it should do, then this isn't a bad place to look after that and to do limits. So limits can be inbuilt into this HMI parameter provider. So instead of just straight up returning this value, you could say, well, if the HMI is asked for it to be over, then no, just limit it and give back the limited value. You may even also want to affect the structure itself. So when the HMI actually asks for it to be changed to that value, the parameter provider just sets it straight back and says, no, that's limited. Because it's a parameter, we'll go read-only on this one. So that means we're going to delete the set access. So now no one can actually change that parameter from outside of, unless they go for the structure itself. And let's just do, actually we might as well do just all of them while we're here. So each one's going to be a property of LReal. It's public. We're going to get rid of their sets. And inside the get, we're just going to say entry speed. Add entry speed. And lastly, exit speed. Add property. Exit speed. Public. Now, if you're doing it the other way around for status, you could, obviously you can keep the get because get's safe, but you would implement the sets, and the sets would go back and set the parameter set. So you're just going to do the reverse on status usually. So exit speed is equal to exit speed. Okay, so that's our object made, the one that's dealing with all of the whole thing. So we're just saying, yeah, you are in charge of speaking to the HMI, and it's up to you to become different things, to provide parameters to different people. So it's your job to be this morphing thing. So what we're going to say is, let's start with the infeed module, and we're going to say that the infeed module itself wants parameters. And we'll just keep this simple then. So we're going to say this is, we'll say it has to just be an interface of infeed parameters. I don't usually cut words short, only because I find if I'm doing late night coding, I find it hard to use abbreviations. It doesn't allow me to decipher the code very easily. We're just going to add that to the constructor, and now we can just say this hat.parameters is equal to parameters. We have to do the this dot because we're using the same name in the method input as we are the object's private member. So we have to be explicit and say, no, I want to use this. Had I removed that, you already know this anyway, but had I removed that, it would have just assigned parameters back to its input parameter, which would have got us nowhere. Okay, because they're interfaces, we can just do straight assignments as well, which is good. We do have, with references, check valid reference, that might be handy to do. With interfaces, if you want to do any error catching to say, well, was this truly assigned? Is it correct? Then you just evaluate them to 0, same as any other address. We can copy, and let's just carry on with infeed parameters. So infeed parameters itself, in the HMI parameters, I'd add it into here and just say that I've got a new interface called infeed parameters. And anything that abides by infeed parameters needs to provide me machine set point speed, okay, that, and entry speed. That's it. So I don't care who you are, but you must implement those two. The last step that we need to do is tell our HMI provider that now is that. Implements infeed parameters, which it does, and everything should compile nicely. It won't, because we've now got to pass in as parameters is going to equal the HMI parameter provider. And it's asking for someone who implements that interface, and the HMI parameter provider does. So that's fine. So it compiles nicely. Just to finish up, the final one that we're going to do is the exit module. So we can just copy a lot of this code out. So init, parameters, init, view parameters. We're just going to make that exit parameters, which is, and in the module itself, it's exit parameters. So let's just make sure that compiles. No matching found, which is correct. So we now need to make an exit parameters, which is an interface of exit parameters. And this thing, I may as well copy them from here, is going to have the machine set point. This is going to be the one that it shares. So if someone else ran it, it would just get the same value as the other interface did. So that's fine. But instead of having entry speed, it will have exit speed. And let's just paste that in properly. So yes to that. So we've now got these two parameters. So each interface just provides two parameters only in this example. Last thing we have to do is just add that to the implementation of what the parameter provider can take. Just compile that. And now we don't have a valid FB init for this one either, so we can just copy that one straight out and say, there we go. Your parameters are also provided by the HMI parameter provider because it can be that thing. It can morph into it. What have we got as the last thing here? So you'll probably see this error before I will. What do we have? HMI parameter provider. Oh, there we go. Simple as that. No errors, no warnings. What we can do, just as a small test of this now, so our in-feed module, we can say if parameters dot. We can see we've only got access to the two that we made available in the interface. So we can now say if the machine set point is greater than 0, then motor dot run at speed parameters dot entry speed else motor stop something just trivial. What we got here? Run at speed. I didn't actually finish my motor module. Let me just put that in just so we've got it. Run at speed. That's going to require speed. That's that well. And because it's an interface I'm passing in, we have to make sure that we correct the interface so it matches. We're good to go. Okay. What I'm doing is I'm just cyclically calling these modules here just so we can see them. And let's just activate the configuration. Just make sure this all powers up as we'd expect it to. Port is disabled. Okay, that's it, because I'm currently logging on the other screen with my real-time monitor. Okay, all right. So anyway, I'll send you a copy of this. I'll just make sure it does actually build okay, but we won't do debugging right now. Actually, debugging, there we go. Let's just have a quick look. So what we were saying before is it possible to see anywhere else that entry speed has been used? So find all references. So it's found parameters entry speed in here. So if we had, actually speed set point, let's just do that one because I can copy that into this one here. And instead of this is going to be exit speed. Okay, so that's our code written. But now we need to see where all find references of machine speed set point. So no, that's at that point there, it's only classing it as an input itself, saying it can see everywhere where inside this function block it's being used. And can we see it from the actual parameters itself? So if we have a look at the HMI, we'll do machine set point speed. So I don't think that's doing any updates for us. So machine set point is in the exit module, so that's that exit one. So we can see it'll actually drive in and tell us where it's being used as an interface. And then if I do it on this one, machine set point speed, no, it doesn't know. Gets, let's just save in here. Gets and sets, no, that's internal as well. Machine set point, no. So there we go. And also as well, set point speeds, that's just going to be inside the parameters itself. Yeah, I don't know really, because I don't know. Had you passed in a structure via a reference to, I think you'd probably suffer with the same problem. because as far as it's concerned, it's just a reference to something, and therefore it's a new thing that you're owning inside, and therefore it'll only do discovery there. One thing we could see if it works is inside the infeed module and machine set point speed. Can we do go to definition, property public of that one, and go to definition. That'll only go up as high as the infeed, as the interface itself. And I suppose that makes sense, because if you think there's no limit to how many objects behind the scenes can implement the interface, which is one of the beauties of interfaces. I may have 15 different in-feed parameter providers. In this instance, one's coming from the HMI. We may have one that comes from a database, one that comes from the internet, MQTT. So yeah, I suppose it can't resolve who is the true owner of that. In this instance, we would just have to go back in, say where does parameters come from? We would see it's via the initialization, and then inside the GVL, we'd see that it's the HMI provider that's doing it. But hopefully that resolves the issue anyway, because no one should be able to write onto that. And if we try to write onto it, I think we should get a compiler error, unlike a structure. So if we were to say parameters machine speed set point is equal to 55 or 33, save, compile. Yeah, no valid assignment target. So I suppose that's one of the, going back to the whole, let's not, I know it sounds ridiculous, but let's not write bugs. I suppose the difference you have from a structure to using this interface technique is structures anyone can write. It's just like a global variable. It depends on where you've defined it, but anyone has access to just hit that value. Or if you wrap it in an object, you've got not only the protection of the object saying no, you're not even allowed to write to this. You can read it, but not write to it. But you also have that added protection of saying if you need to apply limits or enforce limits, the thing that's looking after that can do that. So that's not a bad way of protecting your code. And yeah, you're just going to get a compiler error if you try to write to it in a place that you shouldn't have written to it. Sounds good. Right, I'll send you this now. Cheers, bye.